You can draw a box plot at home, but the most important part is for me to find the median, quartiles, 5-number summary to make sure you understood everything. Are you done with 5-number summary? Sure? All of you? Okay, let me solve this because still I need to talk about one more thing. I don't want to be behind. Okay? So, tell me all the numbers from minimum to the maximum, please.
12, 14, 15, 17, 18, 19, 20, 21, 22, 23, 25, 26.
I'm behind.
26,
26.
28, and 37.
37?
Yes.
7, 8, 9, 10, 11, 12, 13, 14. So we have 14 observations. So let's draw a stem and leaf plot first. How many stems we have? What are those? 1, 2. Let me write down the original one and then we will split that. 1, 2, 3. Front of 1, 2, 4, 5, 7, 8, 9. Front of 2, 0, 1,
2, 3, 5, 6, 8.
correct?
Yes.
3,
7.
7. Correct? Split this. 1, 1, 2, 2, 3, 3. All the numbers, all the leaves from 0 to 4. What are those?
2 and 4.
4. Correct?
Yes.
The second one, all the numbers from 5 to 9.
5, 7, 8, 9.
Correct. Front of the first 2, all the numbers from 0 to
0, 1, 2.
correct? All the numbers from 0 to 4. What is this one?
5, 6, 8.
And then what about the first 3? Nothing, because we don't have any leaves from 0 to 4. What about this one? 7. Good? So now, what is the minimum here? 12. What is the maximum? 37. We want to find the median, correct? Formula for median says n plus 1 divided by 2. This is the location of median, correct? How many numbers we have? 14. Plus 1 divided by 2. Correct? 15 divided by 2 is? Am I right? 7.5. 7.5 is between two numbers, between location. Between location 7 and location 8. Correct? So we organized all the data already. Now we should count. 1, 2, 3, 4, 5, 6. This is observation number 7. This is observation number 8. So observation number 7 is 20. Observation number 8 is 21. What we do? Divide by 2. This is median. We have 41 divided by 2, which is 20.5. This is median, correct? So here we have the median, which is 20.5. Correct? So now I'm going to make my first data set from here to here. So both of our examples today, we had 14 number of observations in the same way, correct? We could have different data set, and maybe the way we calculate Q would be different. No, I mean the way is not different. The location would be in middle or something like that. Okay, so now we know that Q1 is midpoint for this data set, Q3 is midpoint for this data set. Okay, let's choose the lazy one. Cross this one, 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 cross this one. This is
Q1.
okay. The first quarter is the midpoint for the first data set or the data set on the left side of median. Okay, Q1. And then Q3 is the midpoint to the data set on the right side of median. Cross the first one, cross the last one, last one, first one, last one, first one. Am I right?
Yes.
Q3 is 25. So the 5-number summary is minimum 12, Q1 17. Let me write down here. Median 20.5. Q3 25. Maximum. This is 5-number summary. Correct? Oh, good. Do you have any questions so far? So let's draw a box plot. Okay, we have time. Okay, from 12 to 37. Let's make them, okay, 5. 5 is good. 5, 10, 15, 20, 25, 30, 35, 40. Correct? And then, let's say, what is the data set? Calories? Oh, what is that? Number of cardiograms? Okay. Minimum was 12. Right?
Yes.
Maximum is 37. Correct? Q1 is 17. Q3 is here. This one. Then median is almost here, huh? Maybe almost here. And then connect them. You have mean. Q1, M. This is Q3, not QM. This is maximum. Correct? So, let us. What do you describe the shape? How you describe the shape if you rotate it? Minimum.
It'll be
Right skew.
skewed.
Right askew. So we said median is around the peak, correct? And then it extends to the right side. Okay? Just rotate it to this side. So now I want to again talk about the percentage. So what percent from minimum to Q1? 25%. What percent Q1 to median? 25%. What percent median to Q3? 25%. Q3 to maximum? 25%. Okay, so now my last thing that I want to talk about. Do you have any question? Do you remember last time we were talking about resistance measure? Yes, I talked about resistance measure. We said if we add outlier to our data set, that outlier will change mean a lot, correct? But it doesn't change median that much. So that's why median is what? Resistant to the outlier. But mean is not resistant to the outlier. Median was resistant because it was a midpoint. It just changed a little bit, correct? Now my question is that, between quartiles and standard deviation, how they will change with the effect of outlier, which one is resistant, which one is not resistant. I'm not talking about median now. I'm comparing quartiles and the standard deviation. Why? Exactly. That was good actually explanation. It has also meaning inside the formula. That's why standard deviation is not resistant. It changes a lot. Correct? Or it's a summation also, you know? So if you add a huge number, it will change a lot. So quartiles are what? Resistant. Why? It's like a median. Good. Because it's a midpoint, still quartiles are midpoint, right? That's why. So quartiles are resistant to the outlier. But the standard deviation is not resistant to the outlier.